if you find any surface drains. Sometimes they're just area drains. They just, go 2 feet into the ground and then they just disperse the water into the ground. And a lot of these rain gutters either get filled up or have holes in them or are not galvanized, so they go through a corrosion process and, they start leaking water right next to the structure. So it's always good to have these inspections regularly done, especially with respect to the rain gutters and the downspout. Rain gutters and downspouts that's like your first line of defense. All right, we're going to talk about the exterior drainage as the first thing because that's the easiest thing. That's something that you can see as you walk around the property. It has a lot to do with how the lot is actually sloped. If it's a flat lot, if it's a cut and fill flat building pad, or if it is like a sloped hillside lot that where the water follows the direction of the slope, those things that we can easily check by walking around the property. If you find any surface drains, like these little cast iron grates, or if you find smaller surface drains that let the surface water drain into it, sometimes they're just area drains. They just, go 2 feet into the ground and then they just disperse the water into the ground. Sometimes they're tied to a subsurface drainage system that takes the water out and away from the structures. Like if you have, let's say, a 6,000 square feet lot and you have a home that is about 1,500 square feet, and you put a drain system around it that's, exterior, that's subsurface, you want to take the water all the way away from the structure so that there's no way for the water to recede back towards the structure, right? That's what we're talking about here.
This is where are they draining the water? They are draining to storm drains, or do they go into the sewage systems?
Neither. So the storm drains is probably the right answer because you're not allowed to directly tie the water into the storm drain system these days because the cities have a lot of cities and counties have a lot of restrictions on it. You might see older homes having these curb cutouts where the subsurface drains are tied to that curb and the water starts coming out through these curbs. Most cities and counties have now restricted putting in new curb cutouts for these water lines to come out. You cannot tie that into the sewer lines because that increases the volume that has to be processed by the sewer systems. So that is also not a directly allowed situation. What is allowed in most cases is that you drain the water on your front lawn such that the front lawn slopes towards the street. So you can drain it on your own property. You still have to follow a little bit of setback so that it's not directly draining onto the streets. So you can drain it like roughly 5 feet or more from the property line on your front lawn. And the water has to gently cascade or recede down and flow into the streets, which will eventually flow into the Bay Area drain. So yeah, there's some restrictions on how you can establish exterior drainage. So today we have all these, codes and design improvements that we can follow, the guidelines and everything that we can follow. And people started involving a civil engineer apart from a structural engineer, even for single-family residences. So that way they can control the drainage inside and outside the property and make sure that they're never encountering a flood situation or they're definitely staying above the floodplain elevation for that particular location. So it's becoming a habit that more new construction is involving a civil engineer who designs specifically the drainage and the grading part of the entire property. And then there's a structural engineer that designs the whole structure based on the forces that'll act on it. So that way, more new construction is getting better drainage systems, better rain gutters and downspouts. A lot of these downspouts today are getting tied into the subsurface drains that get taken out and away from the structure. Back in the day, even rain gutters and downspouts were not continuously throughout the roof perimeter and at the right locations. And a lot of these rain gutters either get filled up or have holes in them or are not galvanized, so they go through a corrosion process and they start leaking water right next to the structure. So it's always good to have these inspections regularly done, especially with respect to the rain gutters and the downspout. People kind of disregard the roof area. The roof area is a larger area that, when it rains, the water directly lands on the roof, slopes down your roof, and it has to hit a channel, which is the rain gutter. If you don't have one, and if it's not sloped properly to a downspout that takes the water away from the structure, then you have water that directly falls next to the foundation, goes into the crawl space, starts stirring up the soil, and then you have all kinds of movement and all kinds of damages that you can see. It is a slow
Wow.
process. It's not like in 1 year you could see it. Although there have been situations where in just 1 year's worth of rain, we have seen significant amount of movement in certain structures. But typically it happens as a slow process. So if you have that same situation happening for like 5 to 10 years, where you were 5 to 10 years ago would not be the same as where you are today with respect to the floor elevation, with respect to how the foundation or the crawl space has been behaving all these years. So rain gutters and
Wow.
downspouts are typically one of the first things that we note in our inspections to see if that's like your first line of defense, right? You know, when it rains, water falls on the structure. Is that water getting taken away from the structure? Simple as that. People in September put a ladder against the roof. They say, honey, I'm going to go up and clean the gutters, right? And they take a 6-pack and sit there. And a lot of times in October or like in November or December, we get a call. And they're like, honey, I thought you cleaned the gutters. Like, well, apparently not. We wouldn't be there if you had. So also inside the crawl spaces, you know, when you're wondering why they thought to put it this way and not the way that it's supposed to be, and you look around, you find some beer cans, and that explains it. But I think they even made a commercial about that. Like, you know, where a couple of guys, they take a 6-pack and go on the roof and sit and have some, you know, fun time. And they say the excuse that they give is that they're going to clean the gutters and clean the roof. But if that's done properly during September, before the rains hit, then it doesn't clog the gutter system or the downspouts. And you can make sure that it's flushed and cleaned and it's serviceable. So water does not overflow your gutters and, you know, drain next to the structure. So that's very important. And it's a simple stuff. Everybody can do it. Just get an extension ladder and slap it against the structure. Easy done. Signs of exterior drainage problems. I mean, it's pretty straightforward. I've seen so many realtors walk around the property and come up with pretty much 90% of everything that's going on with respect to exterior drainage. You know, water pooling next to the structure, water intrusion. You can see some low spots next to the foundation, efflorescence on the concrete. Most times you see that on the inner surface of the foundation. You don't see necessarily on the outer surface, but there have been situations where it's, you know, stagnant water on the exterior perimeter leaves a white powder deposit. And then the, you know, foundation cracks, mostly if they're vertical, that lets the water into the crawl space. Horizontal cracks also let water into the crawl space, but verticals are, you know, easy to form. You can see a lot of them in foundations. It's quite typical. And once they start to widen, the reason for that also has to do with, you know, if there's moisture in the soil and that starts to move the foundation. And then, you know, if there's any evidence of settlement, that means you might be having a drainage issue, damp soil inside the crawl space, and you know, higher relative humidity. We're going to talk about relative humidity in detail because that's something that, you know, seldom gets checked, but it can become a pretty big villain in the picture of crawl space.
Right.
Just a simple illustration here to show how the water flows. You know, basically we're showing a downspout that slopes on a positive slope away from the structure. If you don't have that, then the water flows back towards the foundation, gets into the crawl space, and you have, you know, all kinds of chaos in there. So our standard recommendation is to, you know, make sure that there's positive grade. Positive grade means you have a minimum of a 2 to 5% slope away from the structure, that, you know, be it landscaping or it can be a hardscape concrete structure or pavers, whatever it is, you just make sure that you slope that away from the structure, because it takes time for the water to go upstream and hit your foundation and go under it or through it. That's what you're trying to do here. You're buying time to prevent that water from coming back towards the structure. And in that time, most of it will just dissipate into the ground, and then you have it pretty easy. I understand that people like having vegetation and beautiful, you know, bushes and flowers and everything around the structure. And they even put, you know, separate sprinkler systems for these things. But it can also become a problem if they're not properly maintained or properly monitored. Because sprinkler systems, today, there are more sophisticated systems where you can control the direction that it sprays, and you can make sure that most of the water is not sprayed towards the structure. Only a little bit of it still makes its way, but that's, you know, negligible. But when people want to do all of that and they kind of max it out, you're basically creating a situation where there's always going to be damp soil next to the structure, and that's not a good sign. So I understand that people love their, vegetation and their sprinklers and everything, but sometimes you just have to make a little bit of compromise, and your planters and everything have to go a little bit further away from the structure to make sure that the most important part of a lot is that structure is still in serviceable condition. And then there's this, mulch that they put around the structure to, easily make it look nice. That has a tendency to absorb and hold on to that moisture. So it's going to be a constant supply of moisture towards the foundation, once again, resulting in the same situation. So that's, typically everything, or most of the things with respect to the exterior drainage. And here are some photos. To the left, we're seeing a photo of a downspout that is draining directly next to the foundation. And you can see that there is a setback between the foundation and the concrete hardscape, like, right over here. So what that does is this downspout drains next to the foundation. It just keeps all the moisture and the water right there. And then over a course of time, like say several years later, you're seeing cracking in the concrete and you wonder what's going on.
Right.
So that's why we ask people to, provide extensions or connect this into a subsurface so that you're not having that water draining right there. Because let's say a garage is about 400 square feet, right? Out of 400 square feet, you have, let's say you have a simple pitched roof. 200 square feet of water or water collecting on 200 square feet of the garage roof is going to end up on the gutters, and the gutters has one downspout, which is the downspout, let's say, that we're looking at. So you're getting all that water collecting and dumping in this
one area.
Foundation. That's the perspective that people need to have when they're looking at these things. So putting more downspouts can sometimes help. Sloping the gutters the right way can also help, big time. When they install the downspouts, the rain gutters and the downspouts, the sloping would be fine. The downspouts would still be draining onto a positive slope and everything would be good. But in the course of time, like after a few years, you got to go back and check them and make sure that they're still doing the exact same, purpose. They're serving the same purpose per the design intent. So here's a photo on the right, which shows the white powder deposit, which is called efflorescence. It's basically white in color because when water seeps through the concrete has calcium-based minerals, and hence the white powder or white color in the deposit. Sometimes we also encounter pink efflorescence. It depends on the chemical composition that is going through this process. But typically in residential foundation, we encounter only white efflorescence. It's not a direct indication of damage to the concrete. It's just an indication that water has been seeping through. Although I have been in crawl spaces where I've scraped the efflorescence and taken it like and made a snowball out of it. Let's put it that way.
Wow.
Yeah. So water, when it goes through the concrete, it mixes with the minerals in concrete. And because it has a calcium content in the mix of the concrete, it leaves a white powder deposit. So it's basically after the water that has seeped through has dried out, you see the deposits left behind. That's the white sediment that you see on the surface of the foundation. Okay, here's more photos of what we talked about. Rain gutters getting clogged. The photo on the right is actually an exterior sump pump. In some situations where you have so much water in collecting in a lawn area, it's good to have like a sump pump system that is exterior rated, because it goes through a lot of debris and the motor has to be able to churn all of that debris and process it and be able to pump it out. And the pump capacity for exterior sump pumps is usually higher. So in this situation,
why is this sump pump only pulling at the corner there? Why didn't it create a slope, from the corner to get the pulling away from that?
So typically sump pumps are installed in whatever is the lowest spot in the entire terrain. Like if you're inside a crawl space, we find the lowest spot in the basement, or we create a low spot in that basement by means of grading and by means of finishing the concrete to all slope towards one point. And that way we can have all the water in an entire larger area slope towards that sump pump, and the sump pump pumps it out. It takes time for the water to get to the sump pump, and that way the sump pump doesn't get overwhelmed, because if it starts flooding over its head, then it's taking more load than it can actually pump. So we have different horsepower for different pumps. Typically in a simple crawl space, let's say that's about 1,500 square feet. A single sump pump that is 1/3 horsepower is good enough to pump all the water out, but you have to have good drain systems that lead towards that sump pump. In an exterior situation, we kind of go, somewhere between 1/3 horsepower to 1 horsepower, depending on the area, that you want the water to flow towards the sump pump and the volume of water that's going to collect, and the type of or the situation in which it's installed. So if it's an interior situation, you already have a pipe drain system that leads up to it. If it's an exterior situation, you also have the lawn, all the dirt and the silt that gets collected into that system, and it takes some time and more power for that water to be pumped out. And a lot of times the horsepower is needed to get head clearance. Like if you're pumping up a really good slope or a really good height to get out of that situation, then you need more horsepower. So this photo on the right is basically a clogged sump pump that has gone unnoticed, unattended, and has not been serviced for a long time. So in these situations, we do a simple float test to see if it's still functional, if it's able to pump the water out, and what's going on. And more importantly, just because you have a sump pump doesn't necessarily mean that the drainage problem vanishes. Number one, is the pump functional? Number two, is water going towards that sump pump? Number three, how much water is actually going towards that sump pump? And if there are areas that you thought was going to send all the water towards the sump pump, but in reality, it's not actually doing that. So there are so many things that is involved. Home inspectors put in their report that, there's a sump pump and, we lifted the flow, it's functional, all that, yada, yada, yada. But there's no talk about whether there's proper drain system that eventually lead to the sump pump, because you can't expect a sump pump in one corner of a crawl space or one corner of a property to collect the water from the other corner unless there are means manually made to have that water flow towards it. More scary photos, cracks due to corrosion of rebar. So drainage issues or water collecting next to the foundation can result in situations like these. On the exterior, it looks like a relatively simple crack. On the interior, this is close to what it's going to look like when it starts to crack and exposes the rebar, corrodes the rebar to a significant effect. And a part of it is concrete spalling, but the reason that the concrete is spalling is because of the corrosion in the rebar. When the rebar corrodes, it starts to form a passive layer around it, and that pushes the concrete around the rebar. So studies have been done to find out how much the rebar corrosion can actually increase in the rebar size, and it can go up to 6 times its diameter. Let's say you have a 1/2-inch rebar, number 4.
Wow.
At its maximum corrosion, if the passive layer keeps forming around it, it can go up to 6 times the diameter. So that means 3 inches, a 1/2-inch rebar goes up to 3 inches. That's what pushes the concrete around, and you see a horizontal pattern of cracking that is directly parallel to the rebar. So let's put it this way. I like to call corrosion as the cancer in concrete, in reinforced concrete. It's a slow process. It's happening in the background. There's not a lot of tests that you can do to non-destructively, although there are equipments today that you can use to non-destructively test corrosion potential in a rebar, but you would have to partially destruct. You would have to poke and probe into the concrete, directly tie into the rebar to find out how much corrosion activity is going on in it. And you can also find out if there's an ongoing corrosion that's significant that you would have to replace the rebar to make sure that the concrete integrity is maintained. Prevention is pretty easy. Maintain your rain gutters and downspouts, your subsurface lines, ensure positive drainage around the property. You can also choose to install a French drain. People misunderstand a French drain to a subsurface drain. A lot of times French drain is something that can collect the water along its pathway. So French drain pipes are perforated pipes. They let the water into that pipe system and they take it away from the structure. If you put a solid pipe that just simply connects to the downspout, that is not going to collect the water on its way. So it's not a all-round protection for your foundation. It's just going to be protection at certain points where the downspouts come down. So there has to be I'm trying to educate more people on the difference between a French drain and a simple solid surface subsurface drain where you just collects water from one point and takes it to the other. These are some details that we typically use in our design. You can see downspout connections into subsurface. You can see a flow spreader. When you have a hillside, you don't want the water to flow at a much faster pace, so you kind of want to slow that down. So it's kind of spreads the flow on that hill slope. You also have a surface drain detail. We design the drainage for an entire property or an entire lot, and we put these details together. These are photos of after drain systems have been installed. That's an exterior drain system. It's just connecting a downspout, but it still has to go through a trench. On the right, we have an illustration of a foundation that has a drain board and has a perforated pipe and has drain rocks that kind of stabilize and give that slope for the water to continuously flow by gravity towards where it has to go. And now we're entering into crawl space drainage. This is going to be this, kind of like the scary part. And like I said in the beginning of my talk, we oftentimes swim inside crawl spaces. And when it's too, when the water level is too high, we take temporary pumps and put them down there. We pump the water out. So there's limited amount of water where we can swim, because it also prevents us from being able to inspect different parts of the foundation and the framing support. So taking all that water out is step number one, having very minimal amount of water, and then doing an inspection to find out where this water is coming from and how it's affecting the structure and its support, and the connections is the next step. So typically damp soil in a crawl space that never dies, big problem. Standing water, all of these can lead to corrosion in any kind of metal hardware. That's why typical recommendation is to use galvanized metal as a bare minimum. It has to be minimally galvanized. Even the zinc coated stuff, sometimes like, simple coatings, they wear off after a certain time, and then, it starts to corrode that metal hardware a lot. So galvanized metals are way better. Hot dip galvanized, even better. Stainless steel, top notch, right? So basically going up on the protective scale. And then your rot and termite damage issues, or water damage issues, fungus damage. Needing proper drainage for crawl space, we talked about it. We need proper clearance in the crawl space. It's always a situation where we end up having to dig the soil to get access to different parts of the crawl space. Putting a drain system throughout the entire crawl space is important if you have standing water in different parts of it and you want to collect them all together in one spot. Put a sump pump and take that water away. These are some scary situations where you have standing water. You can see that the beam is super shallow and we have to go under that, but that's, kind of where we start to swim in that little pond over there. These are details of how we do drain systems inside a crawl space. If we're going against the entire interior perimeter of the foundation, we need to be about a certain 45-degree line. So that way we're not causing undermining of the foundation, because we're excavating and putting the system in. The foundation has to be stable, and you don't want it to kind of tilt sideways and lose its lateral bearing. So we try to keep that above that 45-degree line to prevent it from undermining. You'll see that terminology mentioned in a lot of inspection reports. It's basically like taking the footing out of the way. On the right-hand side, you see a sump pump detail. It's pretty standard, straightforward. It gets put inside a sump pump bucket with the filter fabric and the drain rocks and everything. Has its own one-way valve so that the water doesn't flow back towards the sump pump, and basically gets the discharge terminating outside of the structure. These are typical installations of crawl space drainage systems. Going from the left, you see that filter fabric. That's the black colored fabric sheet that you see. That's the first thing that goes into the trench. It filters out the dirt and lets only the water seep through. And then we have the perforated pipe system that is now covered by the volcanic rocks. At the bottom, we use drain rocks to stabilize the pipe. And then sometimes we fill it all the way with drain rocks. Sometimes we just top the top 4 inches with a volcanic rock, because you want it to make it look a little nicer, which leads to a sump pump, which is on the third photo. It comes with its own GFI protected breaker. That's a 20 amp breaker dedicated on your sub panel or main panel, specifically for the sump pump. So you can, if it trips off, you can turn it back on. And the sump pump servicing is very important. Just because you put a sump pump and a drain system doesn't necessarily mean that it's always going to be functional. You have to make sure that the motor is fine. You have to make sure there isn't anything stuck in it, and ensure functionality. The last photo on the right is basically 2 pop-up emitters. So all the water from the sump pump gets discharged into these 1.5-inch lines, which turn into 3-inch or 3.5-inch pop-up lines. This is what's installed at the front lawn. So water basically hits that pop-up, flows down through the front lawn and eventually ends up on the street, which is an acceptable situation in most cities and counties. And here's a basement illustration just showing you the entry points for water to get into a basement. It can come from underneath the slab and you have a crack. Even when you don't have a crack, a lot of old basements don't have a vapor retarder or a vapor barrier underneath the slab. So water can eventually seep through the slab and come up into the basement. You also have cracks in the retaining walls for the basement, or you can even have a waterproofing failure on the outside that lets the water seep through. The intersection of the slab and the retaining wall and the footing, that key intersection can also let water come through. So a lot of times on a retrofit situation, they get sealed using various applications. And then you have your window wells or vent locations or typical basement windows that can also have water seep through or moisture seep through into the basement. Here's another photo on the left-hand side, an illustration of how a basement drainage and waterproofing is done. You see the drain mat, you see the that's an asphalt-based foundation sealer, but now we're using a lot of different products for waterproofing the basement on the positive side or on the outer side. The soil side is usually called the positive side. The inner side of the basement is called the negative side. You don't always want to excavate soil to check your waterproofing or to redo the waterproofing. So sometimes negative side waterproofing or waterproofing from the inside of the basement is also an approach that is handled to reduce cost for waterproofing basements. On the right-hand side, we see the drain system leading to a sump pump in the basement, collects the water underneath the slab. Whatever enters through the retaining wall goes through the weep holes, gets down into that drain system, goes to the sump pump, and then gets pumped out. In a situation like this, where it has to climb the height of the basement wall and go out, most cases, a 1/3 horsepower sump pump would still be functional, but it's better to go for a 1/2 horsepower or higher to make sure that the water absolutely gets pumped out of the basement.